Now, in this problem, we have a 100-kilogram object sliding down a 20-meter slide with a 40-degree incline angle. Now, the problem gives us the coefficient of friction that we see it's acting on our object, and it also gives us the velocity in which the object hits the spring and the resistance of said spring. We want to know how much distance does the spring retract when the object hits it. So the first thing we gotta do is do ourselves our force diagram. We know that the object is putting pressure downwards. That's the weight, force of weight. And perpendicular to that force, we have the normal weight, which will be here. And as we know from the problem, we have a force of friction acting against our object. So our force diagram would look a little bit like this. You see, we have the normal force here, perpendicular to our force of weight, and the force of friction acting on our object, which would be right here, this dot right here. Now, the first thing we should do is take a look at the conservation of energy formula we have right here. So first we analyze how much kinetic energy does our problem have at the beginning, our initial kinetic energy, plus our gravitational energy initial. This U represents the potential energy. So we have these two that are acting on our initial that are equal to all the finals. So it will be kinetic energy final plus potential energy final plus work plus the spring resistance. Now let's put those formulas in our equation. So we know that kinetic energy formula has 1/2 of mv squared, right? So we put that here, plug it in, plus the potential energy. That will be mass times gravity times height, alright? That will be equal to the kinetic energy final, that in this case would be 0, as well as the potential energy. It would be 0, 0. But we do, however, have work, so we have force over distance, and the resistance of the spring. So we have 1/2 kx squared. At the end, this is the formula we're going to work with. 1/2 mv squared plus mgh is equal to the force of friction, the coefficient of force of friction that is given in the problem right here, times the weight in y times the distance. Why does it happen? Because our force is, in this case, the force of friction. And the formula for force of friction is this one. So we just plug this formula in this formula and vice versa. Plus the resistance of the spring will be 1/2 of kx squared. Now, let's move on to the second part of our problem. By now, we should have realized that we don't have two variables to solve the problem. We do not have the height of the problem, nor the weight in y. So that's exactly what we're going to do next. Now, for the height, it's really quite simple. Since we're dealing with a triangle, we have our hypotenuse, that would be 20 meters, and our angle, we have a 40-degree angle. So with those numbers, we can easily use SOHCAHTOA, in this case sine, to get the unknown variable. It will be y. So we solve for it, and we'll be sine of 40-degree angle is equal to y over hypotenuse. In this case it's 20. So at the end we have sine 40 times 20 equals y. So y is equal to 12.86 meters. That was fairly easy. Now, a similar thing is going to happen when we try to solve for the weight in y. In this case, we need our force diagram again. We draw an imaginary axis here on the weight. This is the y-axis, and this will be the x-axis. In this type of problems, we should try to get the force of weight as our hypotenuse. Now I'm just going to copy this exact imaginary triangle. Is the exact same as we have in the problem, just like mirrored. Now first we have to get the force of weight. How do we do that? That's fairly easy. Weight is equals mass times gravity. That would be 100 kilograms times 9.81. In this case it's negative. So our weight would be 981 or minus 981, depends on how you do it. And with that, we can solve for our weight in y. Now we're going to apply the reciprocal angle. So we have a 40-degree angle here that tells us that this angle right here should also be 40. With that data, it's again really easy to solve for the unknown side. But this time we use cosine. So we have cosine of 40 is equal to weight in y over the hypotenuse, the weight. At the end we have cosine of 40 times the weight is equal to weight in y. And after that multiplication, we have that the weight in y is minus 751.5 newtons. We have done the hard part of our problem. Now we have to go back to our formula and plug in the values we just found. This is how our problem looks now. We have the formula we started with, and we're just going to plug in the values we found to solve for the unknown variable x. This is the distance. Now we have 1/2 of the mass, that's 100 kilograms, times the velocity, which would be 20, plus mass again would be 100, times gravity, times height, which we just found out. That would be equal to the coefficient of friction, in this case 0.6, times the weight in y, times the distance covered. This plus 1/2 of k, that would be 6x squared. Right? So we have all our values now. Now let's solve for x now. If we do this multiplication in your calculators, you should get this number, right? 116,000. Oh no, wait, 11,615.6. That will be equal to, again, this multiplication should give you this, times 3x squared. Now, the next step is adding this number to this number, and it should give you 78,564.4. That will be equal to 3x squared. Next thing, we should get this 3 dividing over here to isolate x. So we do exactly that, and we have 26,188.13. But that is equal to x squared. So we should do the square root of this number to get x just by himself. When we do that, the result will be x will be equal to 161.82 meters. That's it, and we just solved our problem. We know that when an object is sliding 20 meters and weighs 100 kilograms and hits with 20 meters speed, the spring retracts 161.82 meters.